So yesterday we started out, we had this worksheet where we had this problem where we're taking out this segment of a circle and as a channel in a piece of metal. And you were asked to find the volume of the material removed, the radius of the circle and the volume of the material removed. Anybody want to venture to tell me what the radius was that they calculated? What's that? 0.375? No. 1330 seconds maybe? We can try that. How about volume of the material? Anybody come up with anything? Okay, well, let's take a look.
Why did you flip out a fractional when we were doing?
So here's what we have. We have 3/4 inches across here. We have our 1/4 inch depth. I'm flipping it over just because that's the way we're used to seeing them here. That's supposed to be round, yes. Smart ass. I'm going to call that X for now. This is going to get split into 3/8 and 3/8. And so what we have is 3/8 times 3/8 equals 1/4 times X. This is going to become 9/64. Divide by 1/4. It's going to become 9/16 equals X. So this is 9/16. Well, this is 1/4 would be 4/16. So that adds up to 13/16. That is the diameter of that circle. So the radius is half of that, or 13/30 seconds. So somebody gets their gold star. Radius was correct, 13/30 seconds of an inch. Our volume now. Well, we have to find we're going to find an area, and then of course an area times a distance. To find the area, we have to find the area of this whole sector, which means we need an angle here. What we have is we have the 13/30 seconds radius here, there, and we have the 3/8 here. So I can find this angle and just double it. 13/30 seconds, 3/8. Here's my right angle. Here's the angle I'm looking for. According to that angle, I have opposite and hypotenuse, which is sine. Bringing up my definition of sine. Sine of an angle is opposite over hypotenuse. Do I know the angle? Say no. No. The angle is what I'm looking for here. Opposite sides, the 3/8. Hypotenuse is 13/30 seconds. Which gives us, we're going to do an inverse sine. So second sine. Oops, second sine. 3. Shoot, it's different. If your calculator, you'd be able to use the fraction key. Mine doesn't have one, so I gotta do it this way. 3/8 divided by 13/30 seconds. Yep. So it's 67.38 degrees. And we're going to double that to get the full angle. So 134.76 is the angle here of that whole sector. So now we need to find the area of that sector, which is just going to be the area of the whole circle, pi times 13/30 seconds, radius squared, times my angle, 134.76 over 360. So 3.14 times 13 divided by 32 squared times 134.76 divided by 360. 0.020 it looks like, huh? Inches squared. Look right? 0.194. Let me try it again. 3.14 times.
Close those parentheses on the angles.
Nope, shouldn't have to. Yep, 0.194. You are correct. Don't know what I punched in wrong, but it came up wrong. So there we go, 0.194 square inches. Now we need to find the area of that triangle so we can subtract it out. Well, that triangle was 3/8 here, right? And here it was, well, it was 13 30-seconds minus a quarter. So it's going to get 5 30-seconds here. Right? So that area is 3/8 times 5 30-seconds. Divided by 2, but then times 2 because there's 2 of them. So 3/8 times 5 30-seconds. Then, of course, divided by 2 and times 2 is just going to cancel out, so that's 0.059. Correct? We subtract to get 0.135 inches squared. So that, what we just found there was the area of this segment of a circle. In other words, if we were looking at the end of this, it's this area right here. To find the volume, it's just an area times the distance, so it's that area times 4 inches. So we're going to take 0.135 times 4, which is going to give us 0.540 inches cubed. That's the volume of the material removed, correct? Do you guys concur? How many of you had that answer? A couple. Cool. How many of you have no clue where that answer came from? How many of you want to cry and just go home and suck your thumb for a while? Just.
All right.